Let's start notes for 9.3. The very first shape we're going to talk about is trapezoids. They are quadrilaterals with one pair of parallel sides. So what you're going to have is you have this one piece of a trapezoid and this other piece, and those two pieces are called bases. It has one pair of parallel sides, so that's how come I have this little arrow there. This side is parallel to this side. Those are the two sides that are called a base. What you can get from the area formula on this is it's very similar to a parallelogram if you were to cut it right down the middle. If you were to slice this trapezoid right down the middle, directly in half, you could take this top piece, fold it over, and it would fit right here, and it would turn into a parallelogram. So if I did that, what the formula for the area of a trapezoid would be is this one. It is 1/2 h times b1 plus b2. I'm going to put I'm going to highlight that real quick because we're going to use it. It's a more complicated formula than what you're used to. But think about it. If I were to have a parallelogram, the base wouldn't just be base 2. It would be base 1 falling down over here, base 1 and base 2 added together. That would be your bottom. And then multiplied by half of the height because we cut it in half. You can turn a trapezoid into a parallelogram by doing that. Here's your area formula though. Base 1 and base 2 are the two that are always parallel to each other. So what we're going to do is we're going to do a problem that looks like number 3. And on number 3, we have a trapezoid, and they have it slightly turned on its side. We have a 13 yards, a 7 yards, and a 4 yards. You do have to decide which ones are your bases and which one's your height. So, which one is your height on this particular one? What number? Say it out loud.
7.
7 is correct. The other two numbers are your bases. And don't forget there is order of operations on this whole thing. So, if you have 13 and 4, you need to add those together before you multiply. 17 times 7 and half. If it doesn't work out, if you can't take half of 7 or half of 17 and it doesn't come out nice and even, just multiply it on your calculator and switch it to a decimal. Comes out to half of 7 times 17, which is 59.5 yards squared. Now that you have that, sometimes what you're going to have to do to find the height is you're going to have to use the Pythagorean Theorem. I'm hoping you remember what it was since you learned about it in 7th grade and 8th grade. The Pythagorean Theorem is a squared plus b squared equals c squared. When you have to find the height, use the Pythagorean Theorem. Charlie.
Is that an equation you can test?
This equation you're expected to know. It is it? I don't remember if it's on the formula test or not. But I'm going to highlight it anyways. Let me see if I can answer your question by looking at this. I see some of you writing this down, but this is the chart that is on the back of your check sheet. You got to know that formula, you got to know that formula, you got to know that formula. Circle formulas, rectangles. Pythagorean theorem is there. Distance formula is there as well. So do you have to know that? That's one of your formulas. Yes, absolutely.
Do we have to remember all these formulas for the test?
That's the idea. Okay, so for the formulas on the test, there is a 10 question, do you know these formulas? You take that first. It's worth 10 points on your chapter 9 test. That's where up 10 points or down 10 points depending how many you know. And then you start the actual test, which is worth 90 points. 90 plus the 10 makes 100. And you get to use formulas on the rest of the test. We'll give you the formulas after that point. Does that make sense?
Yeah.
We're going to test you on it. And then if you don't know it, we're going to give them to you. That's how it's going to work. Okay. So let's look at number 6. Let's look at number 6. And I need to zoom in a little bit because that's really far away. Number 6 looks like this. It has an 8 inches right here. It has an H right there. Well, actually, I don't even think it has an H right there. It has 11 inches. It has an 18 inches, and it has a couple of right angle symbols in it. So now that you have that, this problem, this is the height and the 11 is not. If I'm using that formula that we wrote down on here, I don't have a perpendicular height, so I have to figure out what it is. If this is 18 and that is 8, that lets me know that this piece here, this part of the triangle, this distance here is 10. And so what I did is I went over here and I drew the H, I drew the 10, and I put the 11 right there. And then I set up my Pythagorean theorem to be able to solve it. I have a squared plus b squared equals c squared. And if for those of you who don't know or don't remember the Pythagorean theorem, the c squared is always your hypotenuse. It's always the one across from the 90 degrees. Here's the 90. You can think of the 90 as a person pointing up to the C side every single time. That's the one that has to be C. The A and the B's don't matter. You can put the A in the A spot or in the B spot, doesn't matter. And if you do the math here, you get that H is the square root of 21, which is a decimal, and you can plug that decimal into your formula. So literally on number 6, you have to do all this work here to figure out what H is. Then you can go and find your area as well. Okay. Once I find my height, then my B1 and my B2 are pretty simple to plug in. I plug in 18 and 8 for my base 1 and my base 2. My height was root 21, which is about 4.58. Sometimes I don't plug it in until the very end. I could do half of 26. And then I can do 13 times root 21. And I get that the area of that particular shape was 59.6 inches squared. It's a lot of work for one problem, but there's 2 of them on your worksheet that you're going to have to do this for. Looks like some of you are still writing. You good? Good? More time, more time. Still writing.
So the 4.58, which is the square root of 21.
Yep.
You
You can plug that in anytime you want to.
so
I just didn't plug it in until right here. 13 times 4.58, which is 59.6.
Okay.
Now I'm going to turn this over and talk about two other shapes. Two other shapes. They are a rhombus and a kite. If you don't know what a rhombus looks like, a rhombus is a four-sided shape. Think of a square without the right angles. That's what a rhombus looks like. All four sides are the same, but there's not necessarily any right angles with it. So you can use base times height if you want to, but most of the time we're going to use this other formula here, which is 1/2 d1 times d2. That's short for diagonal 1 times diagonal 2. A kite, on the other hand, is where the upper half doesn't necessarily match the bottom half, but they do match each other on both sides. They look like a kite. The neat thing about a rhombus and a kite is that their diagonals are perpendicular. I didn't write that anywhere on here, so I need to write that down. The diagonals are perpendicular for both. When we have this formula d1 and d2, d1 is the length of the full diagonal. That means the distance from one corner all the way to the other corner. And so they are going to try to trick you, and I'll show you what I mean when I give you example number 7. D1 says it's the length of the full diagonal. D2 is the length of the full diagonal as well, just so you're aware. So how do they try to trick you? They try to trick you because sometimes they're going to give you a piece and they're going to say this piece from the center to this corner is 4 feet and from the center to the other corner is 4 feet. That's not the full diagonal. The full diagonal is from here all the way to here, so you're going to have to do some addition sometimes in order to figure out what the diagonal is. This pink diagonal, how long is it?
8 feet.
8. You are exactly right. The orange diagonal isn't 2. It isn't 6.5. It's both of those together. It's what?
8.5.
So when you go into this formula of d1 times d2, half of d1 times d2, you would get 1/2 8 times 8.5. And I can do this in my head because half of 8 is 4. 4 times 8.5 is 34 feet squared.
Does that say 2 feet?
That does say 2 feet, yes. Don't get fooled. Add up that full diagonal. One other little note. Sometimes they're going to give you the distance on the outside. This is a full diagonal. So sometimes it might say 8.5 feet. Sometimes it might be out here and you'll figure out what the diagonal 1 and diagonal 2 is. So don't freak out if it's that way. Okay? We'll stop your notes right there.